last time that we met, we talked about special right triangles. And so today we're going to progress with that further with talking about right triangles with relation to trigonometric ratios. As most of you have probably learned it before, SOHCAHTOA. So for those of you who are trying to remember this, we've got that SOHCAHTOA is your sine, which is consistent of your opposite over your hypotenuse. So if we're looking at angle A, the opposite is going to be here, and your hypotenuse is always that longest side. And when we talk about the cosine is your adjacent over your hypotenuse. That is going to be your adjacent to A, is going to be this one right here, hypotenuse still here. And finally, we have your tangent. Your tangent is going to be the opposite over the adjacent, which I have these all color-coded so you can match them up, which color coding is extremely helpful when you're looking at these problems. So the question is how do we use these trig ratios to find the sine, cosine, and tangent? Now, remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We have here, we need to come up with our ratios for theta, which is what this symbol here is. So our sine is our opposite over our hypotenuse. So we have 9 over 15, which we can divide both those by 3 to get 3 over 5. When we talk about cosine, our cosine is going to be our adjacent over our hypotenuse, which is 12 over 15, which both of those are divisible by 3 to get 4 over 5. And finally, we have our tangent, which our tangent is going to be your opposite over your adjacent, which is 9 over 12, which both of those can be divisible by 3, which gives you 3 over 4. So these 3 answers would be the 3 that I'm looking for. Moving on to another one as another example. We have here sine of theta. Sine of theta is going to be, when we're looking here, our opposite over our hypotenuse, which is 2 over the square root of 5. But if you remember from last trimester, we cannot have a radical in the denominator, so we're going to rationalize by multiplying by the square root of 5 over the square root of 5, which 2 times the square root of 5 is 2 root 5, and square root of 5 to the square root of 5 is 5, because square root of 25 is 5. Then, with reference to our cosine is going to be our adjacent side over our hypotenuse, which is going to be 1 over the square root of 5, which likewise we will rationalize the denominator, which 1 times the square root of 5 is the square root of 5, and square root of 5 times square root of 5 is square root of 25, or 5. And then finally, when we talk about our tangent, we have here opposite over adjacent, which in our case here is 2 over 1, which is 2. Now, the other piece you need to be able to do is show that a statement is true. So we have here that the tangent of A equals 1 over the tangent of B. So if we look here, A is right here. Our tangent of A is going to be our opposite over our adjacent, which is A over B. Likewise, if we're looking at angle B, tangent of B is opposite over adjacent, which is 1 over B over A. But if you remember, when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So we have 1 times A over B, which A over B equals A over B. So I've just proven that the statement is true.